Hey everybody, Lars here. Welcome to the summer version of PMDS Python Methodologies for Data Science. If you have been signed up and you have access, you've already gotten a couple of announcements, and you see that's what the Sakai site should look like. And if you go to Resources and click on Unit 1, I already was there, so let me go back to the beginning. You should see this, and if you click on Unit 1, you'll see the Unit 1 slides. And that's where the Unit 1 slides are. Also, hopefully, you've seen the book, which is Zell. Let me show you that. Because I think I put yes, I did. I put a link to Zell on there. So that's your book. It's only 19 bucks on Amazon. I think it's cheaper than the bookstore, so go to Amazon. Don't tell the bookstore I said that, though. So as far as the reading for Unit 1, you have it. It's there in the resources, and it's there if you get the Zell book. Hopefully, if you're just seeing this now, you get it in the next couple of days, and you get things done. So just as a bit of explanation, every unit breaks down nicely into 1 or 2 sections, except, units 3 and 5 break down into 3 sections. So for each section, I usually do a little YouTube video, just so you can see things in action and you can see things running. So we'll talk more about the class, and we'll talk more about our in-person meeting next Monday at the end of this video. Right now, I'm going to hop right in to Python and get some stuff done. I am assuming, which I know is a big assumption, that you have Python 3.4, run 3.4. You know what? If you run 3.5, it's not the end of the world, but then it's going to be up to you to get the libraries working later in the course. I know for a fact that the libraries we need and we're going to use, Matplotlib and some others, all work with 3.4, and I have instructions for 3.4. I haven't quite sussed everything out for 3.5 yet, which is why, if possible, I tell you to avoid it. But if you do use it, it's not the end of the world. I actually have it over here in Spider and a whole bunch of different Pythons on this system. So if you run different Pythons, that's fine. But if you have 3.4 loaded and you start it up, you should see something like what you're seeing in front of here. I don't have 4.4. I actually gave you the link to 4.4. I have 4.3. I put this on like a year ago. Oh, there you go. February 24th, so a little more than a year ago. Ugh. So when you first fire up idle, this is what you're going to see. So this is the Python interactive window. And truth be told, we can do stuff right here in this window. I can take the variable a and set it equal to 3, and then I can take the variable b and set it equal to 7, and then I can say a plus b, and the interactive window will tell me 10. I can also assign a variable for that amount and then just print it. And I just print it out in the interactive window by showing you what it is. Okay, so these single-digit natural numbers are what we in computer science call integers. Okay, you can also, if you want, have decimals, or what we call floating point numbers. So now when I say D, I get 34.56. So you might be saying to yourself, well, why don't we just do 7.0 for our integers? And that goes, I don't know if I mentioned it in the slides, but that goes back in history. It is much, much easier to store an integer. So if we can use an integer, and we know we're not going to have half of something, like you don't have half of a person, then we use integers. So another data type that we can have is a thing called a string. These are terrible variable names, by the way. I'm just using letters. I can define a string of characters that holds words. So now the variable w, and you can see by these 2 single quotes, holds a string called Lars, and I'll show you how to print that later. Just by way of showing you something neat, you can always put your variable in a function called type, and it tells you what it is. You can see class integer. We're going to learn what classes are later. And I think I can put a float in D. So yes, that'll say class floating point number. Okay, lastly, but certainly not leastly, is our string, and just str denotes a string. Okay, there's another data type that we're going to get to in the second part of your Unit 1 slides called, that's my coffee machine, do not be frightened, called Boolean variables, and they're really simple. They're either true or false, that's it. But we'll talk about that in the second half. So this is some of the basics as far as the Python interactive window is concerned. You don't even have to create a program yet, but most people do create programs, and it's easy to write your program, store it on your disk, and then the next time when you come back, you can bring it right up and have everything waiting for you. So that's what we're going to do. We're going to get started right away with programs. Classically, when we write our first program in computer science, we do something called a hello world. And I am not going to flout convention. I'm going to do just that. Number sign, hashtag, octothorpe, call it what you will. In Python, we use it to make comments. So any comments that you would like to make in your code, you just type a number sign and type something afterwards. This is good so that you can explain your code as you go along. All good code has lots of comments. So I can do that, and then all I'm going to do is print hello world. Let's do that. And there we go. Look at that. As simple as that, I have written my first Python program. So what I'm going to do now is I'm going to save this to my hard drive. Actually, I'm going to save it to the cloud because I have the PMDS directory waiting. And I'm going to call this rev1.py because after I'm done with all of the things we're going to do in here, I am going to put it in Sakai for you guys to have and play with. So, print hello world. I've typed in my program in the file, and I've saved it, and I saved it with a suffix .py, so my system knows that it's a Python program. So now I'm going to run it. What I do to run it is I go up here and I press run. I press run, and then I hit run module. And then the program runs. Now you'll see if you print something or if you do something, the results are here in your interactive window. So when I run my code, it's in the interactive window that the output goes. Let's do a bunch of things with arithmetic, and I can show you. Let's play with arithmetic. So first thing I'm going to do is I'm going to set up my variables again like I did before. We will go same ones. A equals 3 and B equals 7. Now, I'll create a variable name called the sum and make it equal to A plus B. Easy. I will make one called the difference. And I will make that equal to B minus A. I can have the product equal to A times B. That's just the on top of the 8, the asterisk for multiplication. Now, for division, that gets a little kooky. We can do that, which is typical division, or we can do this. That's 2. We'll get to that in a second. Actually, let's get to it now. So then I'm just going to print all of these results. I'm going to print the sum, and then I'm going to print diff, and then product, and then quote, and quote 2. First, let's go up here and notice there's a space up there. So now, when we run this program, first let's do this. File, save. So we've saved our work. Now we're going to say run module. And there we go. So let's see what we got. 10 is the sum, 4 is the difference, 21 is the product. Then you see, whoa, 0.42, blah, 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 or 0. Okay, that is not very illustrative. So let's make B 17. Little bit. No, I don't want that either. Oh, that'll be okay if I flip them. Sure, that's what I'll do. Little bit better. You can see when A is divided by B, you get 5.666666. But the second one, which I call integer division, it's also called floor division, is rounded down. So you always round down. So you won't get your 0.666, because technically if you're working with integers, maybe you want to keep working with integers, and that'll guarantee, that's why I call it integer division. So that'll guarantee that you get an integer as an answer instead of a floating point, which is the real answer. to that particular problem. Okay, two more things I want you to see. One, you can square things. Actually, it's not really squaring things. You can do exponents. So you just do 2 asterisks instead of 1, and then I will square that. But I can also do an exponent. I can do A times B, and we'll take a look at those. All right, actually, let's take a look now. Square, exponent, done, dun, 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 dun. Yay, all right, things work. As you can see, I square 17, and I get 289. And then I raise 17 to the 3rd power, and I get 4913. You see me very quickly, boom, boom, rerunning the program, and you don't see me clicking anything up here. That's because after you've done this for a while, you're just going to click Control-S to save, and then you're going to hit F5 to run. So when you see me running the program real fast, it's because I'm doing Control-S, F5, and as you get used to Python, you are going to know to do that too, and it is going to become second nature to you. You're just going to fix your program up, you're going to go, and it's going to run for you. So no tricks, nothing hidden up my sleeve, nothing in my hands. You'll see you can do all of these things too and run your program just as fast. All right, let's do, for my next trick, let's take a look at modulus. I will say A, and now I will do the % sign, and then B. Print mod. What will this be? 2. Okay, why is that 2? Modulus, or modulo, is basically the remainder of a division operation. It's what's left after you do a proper division. So if I have A, which is 17, and B, which is 3, and I divide into it, what's the remainder? The remainder would be 2, so that is the modulus of the operation. Modulus is very handy to find out if something is a factor of something, if something divides evenly into something. It actually, you'd be surprised, it comes in very useful. And it's going to be useful to you in some of your homework assignments in the future. I know that. So get a look at modulus. Like I said, all of this, don't type it in. You don't have to worry about it. I'm taking this file, and I'm going to upload it to Sakai for you to download and play with on your own later on. Okay? Let's see. We are cooking with gas. You've already done a lot. You know what a comment is. You've used the print function to print things out. You've assigned variables. You've played around with arithmetic operations already. You've done square, exponents, prints out. You have done a bunch of stuff, but we're going to do actually 2 more things. First thing we're going to do is we're going to play with the input function. Now, before we do that, we're going to learn one more thing. And I used to teach this wrong, and I'm not doing it anymore. I'm going to teach it right. Put 3 single quotes in a row, and then come down here and put 3 in a row. And you'll see that all of the text in between those 3 single quotes turns green. Well, if you've noticed before, in idle, green denotes a string. And this is a way that we create a multi-line string in Python. But it's also used by us wily Python programmers as a way to comment. Because if a string just by itself is sitting in the middle of the code, it doesn't really hurt anything. So a lot of programmers use it to block off blocks where you can type instructions and type different explanations. So you see up here after the number sign or octothorpe that idle colors it red. That's a true comment in Python. This is colored green because strings are green, but we're really using it as a comment. I'm using it to block out the code because we're going to do something new, and I don't want to see the hello world and all of this stuff every time we rerun the program. So that's why I'm blocking it out. So you're going to hear me in the future say I'm commenting it out. It really turns it green. It's really turning it into a string, but a lot of people use it for comments. Just so you know, just so you do it ahead of time. A lot of it has to do with having something in the code, it's not really a true comment. And once we get more complicated, you're going to see there's actually a difference, and you might figure out why going forward. But for now, let's play with the input function. You saw up here in our code where we did our arithmetic that we found out a whole lot about 17 and 3. We added it and multiplied it and did all of that stuff, boom, boom, boom. But that program can get boring pretty fast because all we're doing it is for 17 and 3 because those are actually put in the program. We call that hard coding. We have hard coded those numbers in the middle of our program. But if you're not a programmer and you can't go into this file and edit it, then you can't really change it to do other numbers and other things. So, is there a way that we can take input from the user while the program is running? And there is. It's called the input function. So what I'm going to do is I'm going to grab a number. I'm going to call the variable number. And I'm going to make it equal to the input function. And then I'm going to create a string, what we call a string literal. And I'm going to say please, because I'm very polite. And I'm going to say please enter a number. And then comma, no, actually no comma, because we're going to take it in directly. And then whatever I enter when the program runs is going to be put in the variable number. And then what do I want to do? Let's say I want to square it. So I'll say square equals number squared. And then I will print the square of number and comma. Actually, let me say the square of comma, and then I'll print number is square. Okay. So now 3 lines. I say number is equal to input. So when I run the program, it'll ask please enter a number, and then whatever I punch in will go into the variable number. And then down here, I create a variable squ square equal to number raised to the second power or squared. And then I print it. The square of number, which is what I punched in, is the square. So we should be in good shape, right? Right. I'll tell you right now, we're not going to be, but it's going to be interesting. Let's go. I hit Control S to save. I hit F5 to run. Please enter a number. I'm going to enter 20. So the square of 20 is what? 400? We should see 400. We do not see that. We see an error. And do not be scared. I do not expect you to read these errors yet. You will. Eventually, you'll see something like this and you'll know exactly what it is. But right now, we're going to have to take a look at things. The reason I do this is because I want to show you a couple of things. One, we've just run the program, but those variables are still in memory. And we can use the interactive window to look at some of our values and see what we're getting here. So I say, okay, number equals input, please enter a number, and then square equals number times 2. So my thing blew up. Why did it blow up? And it says type error, unsupported operand type for the power function, str and int, string and integer. What? What does that have to do with it? So I come down here and I start putting stuff in. Let's see what number is. So I type in number. And that's 20. Okay, well, square I should get nothing because it blew up. But I type number and I type 20. Well, that's what I put in. But if you notice something about number, it's got single quotes on either side of it. What does that mean? I'll tell you what it means. If you do a quick type on it, it says class string. The input function returns a string and puts a string in the variable number. So I'm assuming I'm going to get a number and that I can do arithmetic operations on it, but I can't because it's a string. A string is like a word, and we don't really do arithmetic to words. We can do some things later that you're going to see. But right now, what I want to do is I want to tell the input statement, hey, whatever I get, I want it to be a number. So what do? I wrap the entire thing in a function called int. Int for integer. This is called casting. This is when you take a variable of one type and turn it into another type. So now, whatever the answer to my input statement is going to be, it's wrapped in this int function, so it's going to be turned into an integer. And then that integer will go into number. And then number can be squared properly, and I think all is going to be right in Python land. The suspense is killing me. Let's run. Enter a number. It's still killing me. I'm going to give it 20 again. Fingers crossed. Let's see what we get. And oh, thank you. So now it works. The square of 20 is 400. Because we had the incorrect types, we couldn't get it to run, but the minute we made the number we entered into an integer, then our arithmetic worked and everything was okay. The reason I do that is to show you casting, to get you used to, assigning variables, but also to do a little bit of troubleshooting. Remember, you can always come here and put in your variables, which is very helpful. And anytime you want to see what kind of variables you have, you can do a type. And it'll tell you this is square is an integer, number is an integer, and all of those different things, okay? All right, that was cool. So we got that out of the way. 1, 2, 3. 1, 2, 3. I'm going to do one more thing, just because I think it's cool. Let's say I have two variables. I'm going to redefine them up here. Well, no, let me stay away from those other things. I'll call these z and y. I'll make z equal to 40. And I will make y equal to 70. Now, I'm going to print z and y. What do we get? 70 and 40. All right. Now, what if we want to swap z and y and make z equal to 70 and y equal to 40? Well, back in the olden days, what we used to do is we used to assign a temp variable, make it equal to z. Then, because we have z saved, we can make z equal to y, and then we can make y equal to the temp variable. Now, when we print z and y, they've been turned around, okay? Now, later on when we get to Unit 4, we're going to talk about sorting and searching, and you're going to see a thing called the bubble sort. And that's usually where the first time you learn about temp variables and why you need to swap variables. But anyway, Python, and you're going to learn this along the way, is a really good language for programmers, and it's a really good language for learning things because it's really intuitive. And Python actually has a really neat way to swap variables, and it's just one line, so you don't have to remember all of these different lines. Actually, we've swapped z and y. Let's go put them back. And the way I'm going to put them back is just like this. I'm going to say zy equals yz, and that's it. Boom. Now when I print it again, zy, actually we don't need these. Forgive my OCD, but that looks better. All right. So now, if I'm not mistaken, we will have put them back in just one line. Because Python has an interesting way of saving variables in memory and allows you to do multiple assignments in one line. And because when you know how Python works, you can realize you can do something like that. In most other languages, your Javas, your Cs, your C++s, you cannot do a swap like you can do in Python. But because we can assign multiple variables in one line, we can do it in Python. So that's neat. That's kind of what Python programmers would call something Pythonic, something unique to Python. People who program in Python are sometimes called Pythonistas. It's a very, very weird bunch of people. So I wanted you to see that, and I thought it was neat, so I figured you could get a look at that. Now, let's do our version of a grand finale, get rid of all of the comments, and if I run the whole thing, give it a 20. Look at that. That's everything we did. That's pretty cool. All right. That's enough for one session. I gave you 4 different things. We looked at some things with the interactive window. We looked at our first program and some arithmetic. We looked at the input function. And we also did a real quick swap just to show you that you can do some neat things with Python, okay? Just in this short little video, think all the stuff we did. You learned about comments. You learned about assigning variables. We played around with arithmetic. We played around with input. We learned a little bit about troubleshooting with the interactive window. You learned how to do a swap. Seems simple, but there's a lot of things that you're absorbing. It may seem complicated now, but trust me, in 3 or 4 weeks, if you go back and look at this video and look at your programming assignment, you're going to laugh because this is the really simple stuff. But right now, it's not simple for you. You're learning, so take your time with it. Get used to it. Watch. That's why I do these YouTube videos. You can watch it as many times as you want, and you can stop it as many times as you want. You can go back and replay it as many times as you want. Okay? So that's the content for this one video. As far as announcements are concerned, hey, today's the first day of class, right? So take it easy. Read the first 2 chapters. I believe chapter 2 up to page 43. Read the slides. Start absorbing everything. I'm going to release the homework assignments Thursday. Some things are going to be truncated this summer because I don't want to ditch any of the content. I want you to get all of the content that the kids who take the class during a regular semester get. So we're compacting things a little bit. But I'm always going to try to get you the homework assignments with a week to go. Because if I'm not mistaken, if you look on the calendar, this unit ends June 9th. So we're going to have our quiz on Thursday, June 9th. I'll get you the homework assignments on Thursday. Hopefully Thursday, I will also get you the second review video. And that way you'll have an entire week with your text, your slides, both review videos, your homework assignments. You'll have all your resources, and you can read and program and absorb these things and get going. Another thing, go to the forums section of Sakai if you've been able to log into Sakai and do your bio so everybody can see who you are and we can all get to know each other, even if it is online. And remember, third thing, Monday we're going to meet in person. The 6th of June is an in-person meeting at the Core Auditorium at 4:30 in the afternoon. We'll do some intro stuff. We'll do some programming stuff. When you get there, a lot of stuff will be explained. I work for the computer science department, and I run a collaborative lab called The Cave, and it's open all summer, and if you need help putting Python on your system or doing some other things or doing your homework, my iLab assistant Jamie is there. I'm going to be there a lot. That's pretty much where I'm going to work out of. So I want you to become familiar with that as well, okay? Read the materials. Check out this video. Everything, you will understand everything. Everything is going to be cool. You've got no worries, all right? I will be in touch via announcement in the next couple days, and hopefully Thursday I will get you the second review video. Thursday, if I am not mistaken, is Game 1, Golden State and Cleveland. So that video may be made after a certain basketball game gets watched. But after that, I'll probably hop on and I'll do it because I think the second video I go through Booleans and some if-then stuff, and it should be interesting and it should be fun and it shouldn't be that much, all right? So you be good. Watch all of this stuff, and I'll be in touch in a couple of days, all right? Welcome to Python for the summer. It's going to be fun. It'll be easy, and we'll all get through it together. And just think, in 2.5 months, you're going to know Python. So, and then you can plunk it down on your resume, and then you can start doing whatever you want to do with it. Data science, Pygame for gaming, all kinds of different stuff, all right? We'll get into it. You're going to have fun. No worries. All right, I'm going to get out of here. You be good, and I'll talk to you later.